Welcome to my channel, dear students and all the viewers. See, today this is the discussion about the fractional calculus. In my messenger, there's a friend given me these two problem, and this is about the fractional calculus. So today, this is the main important. I want to give you some concept of the fractional calculus. Okay, see carefully. So for that, I want to first, so it is possible or not for the fraction of derivative. So let us assume a function like y is equal to, and that is x to the power n. If we differentiate, that is y1, and that would be n into x to the power n minus 1. Okay, and first I am showing this derivative for the integer cases, but when it is a fraction, it is possible or not, we have to show this theorem. So first we differentiate this in the first order when n is an integer, and okay, and 1 2 3, this is an integer, so y1 is equal to n into x to the power n minus 1. So now y2, that would be here n into n minus 1 into x to the power n minus 2. So see, in this case, so n into n minus 1, after that factorial n minus 2, and divided by n minus 2 and x to the power n minus 2. So therefore this is here factorial n and factorial n minus 2 and x to the power n minus 2. So this is the second order derivative. After the nth order derivative, okay, this is n, so kth order derivative. So notation is here k, y suffix k, and that would be here kth order derivative, okay, of y, and that is equal to, the theorem is that, so factorial n, and this is here n minus k and x to the power n minus k. Okay, in that case, k is here fraction. This is an integer. So this is the first order, second order, third order, like that. This is an integer. So in that case, when k is an integer, positive integer, but in this case I want to show k would be a fraction, it is possible or not, we have to show this theorem. So for the factorial, we can write as a gamma function, that is n plus 1, so factorial n is equal to gamma of n plus 1. So actually I am using here the gamma function y, for the gamma function n would be a fraction, maybe it would be a fraction, so that's why I introduce a gamma function of this case. So see, for that n minus k plus 1 into x to the power n minus k. Okay, so in that case, so where k would be a fraction for gamma function, so gamma k, and that will have 0 to infinity, and e to the power minus x and x to the power, and this is k minus 1 and dx. Okay, k minus 1 and dx, where k is more than 0. In this case, here k is a fraction. Okay, where k may be a fraction. Okay, so this is a theorem. So first we want to find the half order derivative of x. So this is, and y means here x. Okay, in that case y means here x. So when y equal to x, so the degree here is 1, so this is degree means here 1, so 1 plus 1, and this is 1, k means here half, this is 1, and x to the power n means 1 and k means half. So this is gamma 2. Gamma 2 means factorial 1 and x to the power half, and this is here 3 by 2, gamma 3 by 2. Gamma n plus 1 is equal to n into gamma n. So from that, this is actually 1. So x to the power half, and 3 by 2 means 1 plus half. So x to the power half and half into gamma half. X to the power half, this is 2 and root pi. Okay. So this is the first case. So 2 into x to the power half, and that is equal to 2 into root over x by pi. Okay. So in case of half, so for the second, when y is equal to half, half can be written as like x to the power 0. So in that case, n here is a 0. So now I want to find the half order derivative of this. So this is half, this is ddx of half, and this is a half into x to the power 0. So this is here. So in that case, the degree of n here is n. So then there is a n plus 1. So gamma here is a 0 plus 1. So here is a okay. So half we are unchanged. So here 0 plus 1. So 0 minus half and plus 1. So n means 0. Okay. So n means 0 and k means half plus 1. And x to the power, that is n means 0 and k means half. So this is actually gamma 1. Gamma 1 means factorial 0. So this is actually 1. So this is here gamma half. Okay, gamma half. And this is 1 over root x. Okay. And gamma half means here root pi and root x. This is 1 over root pi x. So this is your answer. Okay. This is your answer for the second. I think all of you better understood for this problem. So now we have to show this is for that. Now this is here y equal to x. So the differentiation of this is the first order derivative, and that would be here ddx of x is 1. Okay. Here is the half order derivative of this x is this is your answer actually. So now from this theorem again, the half order derivative of this is so this is actually 2 by root pi, 2 by root pi and x to the power half. So this is 2 by root pi, 2 by root pi x to the power half. So this is the half order derivative of, so 2 by root pi. So formula is here. This is nth order, kth order derivative is this. So we need to here half order. So now see degree of x is here half, so this is n means is here half. Okay, so n means here half, so half plus 1. So this is again gamma, n means here half. Okay, this is the degree of x, and the order is here kth order. So in that case, here is the order of x here half, so this is plus 1. Okay, and x to the power, and this is x to the power n minus k. That is n means degree of this x here is half, and kth order is also half. Okay, so this is equal to, so this is here 2 by root pi. Okay, and this is actually, so this is half of gamma half, and this is here gamma 1 means 1, and this is here x to the power 0 means 1. So 2 are cancelled out, 1 by root pi, and gamma half, this is also a root pi, and this is equal to 1. So see, so ddx of x is here 1, and prove the half order derivative of half order derivative of x is here 1 also. So from this theorem we can easily show that if we added these two d, half plus half is 1, so d half, okay, d dx of x, and this is half or half is dx of x here. So this is the mention that the first order, this is the first order. Okay, it's proved. Okay, so this is actually equivalent to, so dy dx from this. Okay, so for the next case is here half order of sine of ax. So sine of ax, so y is equal to sine of ax. In that case, y1 is equal to a into cos of ax, and that is equal to a into sine of pi by 2 plus ax. Same as y2, a square into cos of pi by 2 plus ax. So it can be also written as sine of 90 plus, so 2 into 90 into ax. Okay, so from this theorem, so after the nth order, this is y suffix n, so this is mentioned that the nth order is like that. Okay, and this is here sine x, and that would be here a to the power n, and sine of n into pi by 2 plus ax. Okay, when here is an integer. Okay, in this theorem we showing that the in this case n is a fraction, sorry, integer, but showing that if it is a gamma function, here is an integer, and when it is a gamma function, so k would be a fraction also satisfied for this case. So from here, this is the nth order. Now I want to find here the half order derivative. So in that case, so this is the half order derivative of sine ax. So it will be a to the power half. So a to the power half. Okay. So see, when the order be here n, so degree of a is here n. So the if order be here half, so a to the power half, and sine of, so this is half times of pi by 2 plus ax. See, this is root over a, and sine of pi by 4 plus ax. Okay, so from the same theorem we can easily show that the differentiation of 1/3 derivative of, like let us assume was a y, this is cos ax, so this is y1, this is here y1 is equal, we can write here minus this is here minus a times of sine ax, and this is y1 is equal to a times of cos pi by 2 plus ax. Similarly, from this theorem we can easily find y suffix n is equal to a to the power n and cos of n into pi by 2 plus ax. So therefore, so this is y suffix half. So the half, okay, this is a 1/3 order derivative. So this is 1/3 order derivative of this is, so this is 1/3 and dx of 1/3 order of cos ax. So this is the q root of a and cos of 1/3, this is pi by 6 plus ax. Okay, now here I am showing this theorem is true or false, so that's why I want to use here another derivative of, for the half order derivative of sin x, again half order derivative of sin x. See what happens. See, for this theorem, again differentiation of half order derivative of sin x. Okay, see what happened. So now the derivative of this is here. So from that, root over a into sine of pi by 4 plus ax. So this is here sine of pi by 4 plus ax. Okay. So this is a constant, so it can be written as like that. So this is root a. For this same pattern, so this is the coefficient of x there is a. So the half order derivative we can write a root a and sine of. So from this theorem, sine of n means here half order. So half into pi by 2, and the whole angle is there ax in that case. Sorry, this is whole angle is pi by 4 plus ax. So this is pi by 4 plus ax. This is as a whole angle. In that case, whole angle is here ax. So ax and n times of pi by 2. So here is whole angle is pi by 4 plus x. In that case, half times of again pi by 4. Okay, and this is a pi by 2. I'm wrongly written. So a root a into root a actually a, and sine of pi by 4 plus pi by 4 and ax, a into 90 actually sine 90 plus ax. So this is cos ax, so if now the dx of sine ax, so this is actually a cos x. So match the answer of this theorem. So you can easily write dx of actually sine ax are equivalent. Okay, see, fractional derivative of this to this. Okay, now from this theorem, so again differentiation of this, this is the 1/3. So we want to get a first order, so again we differentiate the 2/3 derivative of that. Okay, so 2/3 of derivative, again differentiation of 2/3 derivative of, and this is actually 1/3 and 2/3, this is 1. So we want to get here the first order, means if we add these two degrees, this order, we want to get here 1. So that's why we again differentiation on this part as a 2/3 order derivative of this. Okay, So from this, so this is here. So this is here. Okay, this is 1/3. A to the power 1/3. And the cos of, and this is cos. So for the nth order, derivative of this is, so a to the power 1/3. So I can rewrite the notation here. 2/3 order derivative of cos of pi by 6 plus x, and that is equal to a to the power 1/3. And 2/3 derivative of this means a to the power 2/3. So a to the power 2/3. This is a to the power 2/3, and cos of, actually this is as a whole angle. This is as a whole angle pi by 6 plus x. But here is n times of pi by 2. This is n times, means 2/3 of this is here pi by 2. Okay. So as the order is here 2/3, so need to here 2/3. So this is a cancel out. If we add these two, so a into cos of 6 and 3, this is pi by 2. Pi by 2 plus x. So this is cos 90 minus x. This is minus a sine xc. So this is actually the ddx of cos x. See? So this is a ddx of cos x. Okay, actually minus a sine x. So theorem is proved. If we differentiate fraction order, in fraction order, it is also prove for this linear order. So the theorem is proof that. Okay, thank you for watching my video.